Hello, my boy. Today, let us see a number show.
A number show. I guess that would be quite fun.
Fun? I bet it will be. See these numbers? Among these, 1, 4, and 9 are perfect square numbers.
Perfect square numbers. What is that? What about the rest?
Yes, perfect squares. Since 1 into 1 gives 1, 2 into 2 gives 4, and 3 into 3 gives 9.
Okay, now I am super confused.
Ha 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 ha! Come, I will teach you all about squares and square roots. Hello and welcome to Notebook. As Dimitri has already made it clear, today we shall discuss the chapter Squares and Square Roots. In the first part of this chapter, we shall deal with the square number and its properties. Friends, whenever we are asked the area of a square, we always say that it is side into side. So, a square having sides of 2 units will have an area of 2 into 2 is equal to 4 square units, or we can denote it as 2 square. Similarly, a square of side 3 units will have an area of 3 into 3 is equal to 9 square units, or 3 square. Hence, the square of a number is the product of the number with the number itself. For example, 4 square is equal to 4 into 4 is equal to 16. And we can say that the square of 4 is 16. Similarly, 5 square is equal to 5 into 5 is equal to 25. And we can say that the square of 5 is 25. So, numbers such as 4, 9, 25, 64, etc. are called perfect squares or square numbers as they represent the square of some natural number. Now friends, if I may ask you, is 30 a square number? Your answer would be no, it is not. This is because 5 square is equal to 25 and 6 square is equal to 36. So, if 30 is a square number, then it must be a square of some natural number between 5 and 6. But there are no natural numbers between 5 and 6. So, 30 is not a square number. There are some very important properties of perfect squares that we need to know. Let us learn about them one by one with some examples for each. The first property is that a number which ends with 2, 3, 7 or 8 is not a perfect square. For example, 42, 53, 67, 98 are not perfect squares. You can check if you want. The second property is that a number which ends in an odd number of zeros is not a perfect square. Let us test this property. The numbers 130, 2000, 6 lakhs end in 10, 3 zeros and 5 zeros respectively. So, these numbers are not perfect squares. The third property states that if a number is divided by 3 and it leaves a remainder 2, then it is not a perfect square. For example, numbers such as 170, 578, 722, etc. are not perfect squares. The fourth property states that when a number is divided by 4 and leaves a remainder 2 or 3, then it is again not a perfect square, such as 654, 798, etc. Coming to the fifth property, the square of any even number is always even. For example, 2 square is equal to 4, 4 square is equal to 16, etc. Similar to the previous property, the sixth property states that the square of an odd number is always odd. For example, 3 square is equal to 9, 5 square is equal to 25, etc. According to the seventh property, the square of a proper fraction is smaller than the fraction itself, such as 2 by 3 whole squared is equal to 4 by 9, and 4 by 9 is less than 2 by 3. The eighth property states that for every natural number n, we have n plus 1 whole squared minus n squared is equal to n plus 1 plus n multiplied by n plus 1 minus n is equal to n plus 1 plus n. Therefore, n plus 1 whole square minus n square is equal to n plus 1 plus n. For example, 37 square minus 36 square is equal to 37 plus 36, that is 73. The ninth property states that for every natural number n, we have sum of first n odd natural numbers is equal to n square. For example, 1 plus 3 plus 5 plus 7 plus 9, that is sum of the first 5 odd numbers, is equal to 5 square, that is 25. The 10th property is very important and is based on Pythagorean triplets. 3 natural numbers a, b and c are said to be a Pythagorean triplet if a square plus b square is equal to c square. For example, 3 square plus 4 square is equal to 9 plus 16, that is 25, is equal to 5 square. So, the numbers 3, 4 and 5 are a Pythagorean triplet. The 11th property states that between two consecutive square numbers, n square and n plus 1 whole squared, there lies 2n non-perfect square numbers.
Before we proceed further into the chapter, let us go through some examples.
If we are asked to find out the perfect square number between 50 and 60, then from our knowledge we can say that 7 square is equal to 49 and 8 square is equal to 64. So we can see that there are no perfect square numbers lying between 50 and 60. Again, if we are asked to find out whether 23453 and 4000 are perfect squares or not, then from our learning of the properties of perfect squares, we can recall that the number 23453 ends with 3 and so it is not a perfect square number, and the number 4000 ends with odd number of zeros, so it is also not a perfect square number. Now, if we are asked to find out how many natural numbers lie between 9 square and 10 square, then from property 11 we can say that n is equal to 9 and n plus 1 is equal to 10. So, total natural numbers between 9 square and 10 square is equal to 2n is equal to 2 into 9, that is 18.
Friends, wasn't that fun to learn? Okay, let us go through one more example then.
So, I ask you to find the sum of 1 plus 3 plus 5 plus 7 plus 9 without adding them. You simply would need to remember property 9 and say that the sum of the first 5 odd numbers is 5 square, that is 25.
Friends, before we conclude this chapter, let us discuss some patterns of square numbers.
We already know triangular numbers from our previous classes. 1, 3, 6, 10, 15, etc. are triangular numbers. If we combine two consecutive triangular numbers, then the result we obtain is a square number, such as 1 plus 3 is equal to 4 is equal to 2 squared, 3 plus 6 is equal to 9, that is 3 squared, etc. We know that 3 squared is equal to 9 is equal to 4 plus 5. So, the square of any odd number, in this case 3, is the sum of the two consecutive positive integers, in this case 4 and 5. Let us see the example 3 into 5 plus 1, that is 16, is equal to 4 square. So we see that when we add 1 to the product of two consecutive odd natural numbers, in this case 3 and 5, then the answer obtained, in this case 16, is a square of the only even natural number between them, in this case 4.
With that concept, we come to the end of our today's discussion. I hope that you have been able to understand square number and its properties. We shall meet you soon in our second video, where we shall get introduced to the concept of finding square roots. Until then, Team Notebook wishes you goodbye.